In this demonstration, we will show how Avidian SafeKit's mirror cluster works using the example of Microsoft SQL Server. The product's real-time replication and automatic failover features will be highlighted. Let's consider two SQL Server nodes. On both nodes, SQL Server has been installed. When we open the folder containing the databases on each node, we can see the list of database names, including the system databases. Let's start the SafeKit console to configure the cluster, beginning with entering the IP addresses of the two nodes. In the GUI, you have an option to create a new LAN and nodes. This can be useful if you want to define a dedicated replication network. After clicking Save and Apply, verify the success of the cluster configuration on both nodes. Now that the cluster is configured, let's proceed with setting up the SQL Server.safe module. Let's start by configuring the automatic startup of the module when the nodes boot. If the module starts as primary at boot, then the application integrated into the module will also start. Open a macro panel. Enter the service names of your application in the startup order, separated by commas. In the example, the list is reduced to Microsoft SQL Server, but you can put other service names for restarting your own application. We are now going to search for the service name of Microsoft SQL Server on this system. To do that, we open the Windows Service Manager and look for it. SafeKit works with any edition of SQL Server, including the free SQL Express. The startup type will be set to manual during module configuration and will be managed by SafeKit at module boot. Copy the service name and paste it into the module configuration. Thanks to the service list, you won't need to write any scripts, which significantly simplifies the integration of your application into a module. Opening the Heartbeat panel reveals a single heartbeat for this module, supporting replication. With a private network configured in the cluster, 2 heartbeats could be set up, allowing replication on a dedicated network and better behavior during main network isolation. You can now define a virtual IP address. This virtual IP address is a third IP address that must be set in the same network as the 2 physical IP addresses of the 2 nodes. In a mirror module, the virtual IP will be set on the network interface of the primary node as an alias IP address. Clients will connect to the virtual IP and will be routed to the primary node. Now let's configure the replication with the path of the folders containing the databases. As you can see, the folders to replicate can be anywhere, even inside the system disk. SafeKit's file-level replication does not require reconfiguring the application data. This would not be possible with a shared storage or with a replication at the disk level. By clicking on the plus icon, you can add new folders to replicate, which contain application data required for the restart of the application on the secondary server. We now open the Checkers panel. For Microsoft SQL Server, the main process, named SQL Server.exe, is monitored. If it fails, a restart of the application is triggered. Additionally, other checkers can be configured, such as custom checkers, TCP, ping, or split-brain checkers. Editing scripts is an optional step and can be skipped, as the restart scripts are already pre-configured. The start_prim script will use the list of services defined in the previous step in the specified order. The stop_prim script will stop them in reverse order. You can also skip the step that sets the default encryption for module communications, such as heartbeats and replication flow. The configuration of the SQL Server module is complete. Now we can proceed to monitor the module. The first time, SafeKit doesn't know that Node 1 has the most up-to-date database directories. Therefore, it's necessary to force the start as primary of the SQL Server module on Node 1. Once the module is started on Node 1 and the SQL service is automatically started, we can then start the module on Node 2. The module on Node 2 will resynchronize the database directories before becoming secondary, ready to restart the SQL service in case of a failure or a stop of Node 1. Let's start SQL Studio. It's a tool for managing SQL databases. Connect the Studio with the SQL service using the built-in system administrator account named SA. We are going to restore the AdventureWorks database. The AdventureWorks database is a sample database provided by Microsoft for SQL Server. With the restore operation, a new database will be created on Node 1 and automatically replicated in real time on Node 2. We can check in the database folder of both nodes that the AdventureWorks database has been created. Now, with SQL Studio, let's make some modifications to a table in AdventureWorks named person.person. Only the modifications made within the table are replicated in real time between Node 1 and Node 2. More precisely, only the changes within the .mdf and .ldf files of AdventureWorks are replicated in real time and synchronously. This ensures no data loss in case of a failover. SafeKit allows easy migration of the SQL service from one node to another by stopping the module on the prim node. The second node then becomes primary and restarts the SQL service. On Node 2, we can check now with SQL Studio that the last modifications made on Node 1 have been replicated in real time. Continue making modifications on Node 2 before restarting the module on Node 1 to verify the resynchronization process. Let's restart the module on Node 1, which will resynchronize the database files in its local folder. After the resynchronization, Node 1 is in the second state and is ready to support a failure or a stop of Node 2. Now, let's simulate a crash of Node 2 by forcing its reboot. The module on Node 1 detects the failure and automatically restarts the SQL service. Now refresh SQL Studio to check that the last modifications made on Node 2 before its crash have been correctly replicated. Node 2 is now booting and the SQL Server module starts, as it has been configured to start automatically at boot. The module will first resynchronize its local database folder before becoming second. This concludes this demonstration. On the website, you will find a free trial and the SQL Server.safe module with a quick installation guide to reproduce this demonstration on your own databases. You will find also other modules for other databases and applications.